Hello and welcome back to another video. I sincerely apologize for not uploading in the past month. I've been busy with school and I'm in the middle of moving, so yeah, that's been a bit stressful and I haven't had time to make another video. The video that I'm about to show you is actually a science project on optics. And it's also my first time doing an animated video, so the audio and picture might be a little bit off, so I apologize for that. And yeah, please enjoy and stick around to the end. Alright, now I'm a stick figure. Yes, this is me down here. Hello, hi. You might be wondering why I became 2 pixels thick. It's because I don't have a proper hologram setup, so I'm just going to be making it in this. So a little bit of history on holograms. Holography was invented in 1948 by Hungarian scientist Dennis Gaber, who won a Nobel Prize for his work. He discovered this by accident when he was trying to improve the quality of electron microscope imagery. However, holograms were not possible until we were able to make a suitable light source, the laser, in 1960. Now you might be thinking of the Princess Leia hologram from Star Wars or the Tupac hologram from Coachella, which wasn't actually a hologram, or maybe Tony Stark's holographic office. Unfortunately, that's not what we're going to be going over in this video. And I apologize in advance because for some reason I can't talk today. In this video we're going to be going over flat holograms, which you might see in a museum and stuff. The closest Hollywood hologram I can think of is actually a Doctor Who painting of the Time War, except they could walk into the painting. We can't do that yet. Alright, enough of Hollywood holograms and back to what they are. A hologram is actually just a regular picture, except it has depth to it. So you could turn the image to the side, and the image would actually change according to your viewing point. This might be a little confusing, but once you actually know how it's made, it does make a bit more sense and does seem a bit more simple. Now there's a few different kinds of ways that you can make a hologram, but in this video we're going to be going over transmission holograms, and those are created by light bouncing off of an object onto a piece of film. But that's just a regular picture, not a hologram, you idiot. Shut up, I'm not done. So yes, as he said, that is how you make a regular picture. However, holograms actually use a second beam of light, which intercepts with the light bouncing off of the object, creating an interference pattern, which then gives the image a sense of depth. Now we should learn how light moves. As many people know, light travels in waves, and depending on the wavelength, the light will be a different color. Red light is the biggest wavelength, blue light is the smallest wavelength, and that's just on the visible spectrum. Now let's look at the structure of a wave. It has low points and it has high points. And when they cross with the second wave, depending on the synchronization, it will either amplify each other or cancel each other out. So if the low points are lined up with the high points on the other wave, they'll cancel each other out. And if the high points are lined up with the high points on the other wave, they'll just amplify each other. Much like in water. And yes, there is a lot more to light than just waves, a lot might be a bit of an understatement, but we won't go over that in this video because we don't actually have enough time. I'll go over that more in depth in a future video or possibly series. Yes, that's how much there is to learn about light. Like I said before, holograms were not actually possible until we invented the laser, which can create a constant beam of light that is the same wavelength, or one color. This is important because in order to get the right interference pattern, the beams will have to be the same wavelength. In order for us to get this, we need a constant one color light beam from the same light source. It might seem difficult on how you can get 2 beams of light from one light source, but it's actually pretty simple. To do this, we're going to use a beam splitter, which is a thin piece of glass with a reflective layer of silver on one side that is so thin that it reflects half of the light and the other half just passes right through the glass like there's nothing there. So we're going to use this to create the setup for our experiment. For the first beam, we have a laser which shines a light into the beam splitter. That beam is reflected in one direction, which is reflected off of a mirror into a magnifying lens and onto the surface that we are capturing the image on. This is going to be the reference beam. Now the second beam is going to go straight through the beam splitter to another mirror, reflecting the light into another magnifying lens onto the object, and then the light bouncing off of the object will go to the surface to capture the image. This is the object beam. But if you just use a regular piece of film, it's going to look like a regular 2D image. You're not a nerd, you're just a dummy. I might be dumb, but I'm not done. Now shut up. The kind of film you would use to create a hologram is a photopolymer film. There are many other materials that you can use for this, but for this example, I'm going to be using a photopolymer film. I don't have time to go over how it works in depth, but the most basic explanation I can give is the film is made of a material that reacts with light, and the larger wavelengths will cause the material to react more, creating a denser or darker spot on the film. And the shorter wavelength, the less of a reaction will happen, and the lighter the spot on the film will be. You need to do this in a pitch black room or else it's not going to work. You also need to minimize as much vibration as you can. So that includes fans, refrigerators, or even cars outside. Once the image is made by exposing the film to the laser light, you can shine a light through the back of the film and you can see the image and all of the details recreated in the film. You'll be able to change your perspective and the image will change as well. The coolest thing about holograms is that if you break a piece of the film, the whole image will still be on that piece. Unlike a regular photo where if you cut a corner off of it, that part of the image is just completely missing. Every part of the film of the hologram has the image imprinted onto it, so you can cut your hologram in half and see the whole hologram still. That's all I have time to go over in this video, but possibly in the next video I'll go more in depth. Now I can stop being 2 pixels and go back to being regular Leo. Thank you so much for watching this video. I hope you enjoyed it. Again, this is my first time animating a video, so if the audio and picture were a little bit off balance, I apologize for that. If you did enjoy the video, please leave a like and let me know what you want to see next. I am going to be doing a few more videos on optics and holograms, and I might actually make a holographic television for my dad. So yeah, if you enjoyed the video, please hit the like button, subscribe if you want to see more. And yeah.